All right, IM2 classes. Today we are dealing with angles and areas of triangles. We're going to be spending a lot of time with triangles. We're going to go over a bunch of different theorems with them. We're going to eventually move into right triangles with Pythagorean theorem and right triangle trigonometry. So we're going to be spending a lot of time with triangles, and this is just the beginning. Starting off with the area of a triangle. The area of a triangle, the simple formula, it's 1/2 times the base times the height. This is a good way to write it. Sometimes we will see it as the area is 1/2 b times h without, this is how I'll write it. And actually, just as a simpler, I like to write it as the base times height divided by 2. It's the same thing, right? But then it's easier for kids to put this into a calculator, think about, well, how do I do 1/2? Multiplying by half, same thing as dividing by 2. So this is usually how I write out this formula. The next thing that's important is any side of the triangle can be the base. A lot of kids like to just say the base has to be what's on the bottom. That does not matter what side the base is. The height is relative to the base. The height goes to the opposite vertex from the base, and it needs to be perpendicular. It has to form a right angle with the base. Whatever side you call a base, doesn't matter which one, whatever you have the measurement from, the height is perpendicular to the opposite perpendicular to the base, and then it goes to the opposite vertex up here. So that's the important thing to remember. Finding the height is real simple. So here we have the base is going to be this part of it, right? This is the base. And so this would be the height over here. So to find the area, again, it's base times height divided by 2. The base is 12, the height is 6.3, and we divide that by 2. Use a calculator to work that out. So 12 times 6.3 all divided by 2 is 37.8. Look at that. That's simple, right? Let's do another example. Here, sometimes the height is outside of it. This looks kind of weird. What's going on? So let me show you something real quick. We're gonna switch to the actual, oh no, it's there. What you want to do is imagine this, rotate around. If I could bring up, here, we'll do this. I think I can. If we go to here, where's the slide? So this slide, we could rotate this, right? And we can see like the 8 is the base. And because the height wouldn't be inside the triangle, that happens sometimes. So you kind of have to imagine the height extending past the vertex opposite of the base is up here. And so the height needs to go straight down to where the base would. So sometimes you see the height outside of the triangle. So let's go back to our problem here. So the area, again, is base times height divided by 2. And this one, the base is 8, the height is 5.3, and we divide it by 2. So 8 times 5.3 divided by 2 is 21.2. All right, moving on. Here we are given the area. So we have the area, and now we are trying to find the base. So we have the base here. This is the height. So we're going to use that same formula. The area is equal to the base times height divided by 2. And I'm going to substitute in what I know. So I know the area is 24.6. So that's going to go in for A, 24.6. The 2 stays there. We don't know what the base is, so I'm going to leave that as B. And the height is 5.4. So now I have an equation to solve that I can solve for the base. So it's all I'm going to do is multiply both sides by 2 to take care of the 2 on the bottom. So times 2 divided by 2 cancels out. So 24.6 times 2 is 49.2. And so I'm just going to rewrite this. B times 5.4 would be 5.4B. I'm just reordering that in a way how we normally see it written out. And then I divide both sides by 5.4 to finish solving. So that one I struggle to do in the head. So I'm going to use a calculator to do that one. That's 9.11111111111. So we're just going to round it to 9.1 is equal to the base. Yeah. Let's do another one like that. So same thing. We don't know the base here. This is the height here. And the area is 23.3. So area is equal to base times height divided by 2. The base, we don't know what it is B. The height is 4.7. We're dividing that by 2, and the area is 23.3. So just plug in the values where you know, and then solve, just like we did last time. I'm going to start off by multiplying by 2. So times 2 times 2. This cancels out. So 2 times 23.3, that is 46.6 is equal to, again, I'm just going to rewrite that in a way we're used to seeing it, 4.7b, 4.7 times b. And then divide by 4.7. So 46.6 which times divided by 4.7 is 9.9. Just go round it to the nearest 10th. 9.9 is equal to B. That's a weird looking 9. That is 9.9. Yeah. All right. Moving on. The triangle sum theorem. We dealt with the sum of the interior angles of any size polygon. We learned a formula for that. Right now we're doing triangle specific. Triangles add up to 180. So if we use that formula that we learned back with polygons in our last unit, n minus 2 times 180, triangles have 3 sides, so the n is 3. So n minus 2 is 1 times 180, so you get 180, right? So it works out. So this is 180. Also, triangles are based on this formula. I'll show it to you in class how that works, but you can split up any shape into a bunch of different triangles. So like a pentagon with 5 sides, you can split it up into 3 triangles. So n minus 2, so that's how you get the interior angle sum. So the triangles always add up to 180. The other cool thing about it, if you take a triangle and just take the angles, any triangle you do, you can fit them together to make a straight line. We have more time in class. This is a nice little exercise to do in class, but we don't have time to do it in class. So we're going to move on. And we just need to remember that these things add up to 180. So find X. All I need to do is add up all these angle measures. So I get 20X plus 98 plus 42, and it adds to 180. All right. Solve this. 98 plus 42 is 140. So you get 20X plus 140 is equal to 180. And then solve for X. I am going to subtract 140 from both sides. So you get 20X is equal to 40. And then divide both sides by 20. So you get X is equal to 2. That's it. All right, so add up all the interior angles and say it equal to 180 and solve. We did a lot of that when we were working with just polygons. We're actually going to skip on to the next thing, so this video doesn't get too long. We're going to talk about the exterior angle theorem. So the exterior angle theorem, so we learned about what exterior angles are last unit. The exterior angles are outside of the polygon. They are supplementary to the interior angle. No matter what the shape is, all the exterior angles add up to 360. But for here, specific for triangles, the exterior angle, all right, this exterior angle here is equal to the opposite interior angles added together. So we have angle D here and then angle B. D is equal to A plus B. All right, and that's going to work with every exterior angle for triangles only. So D is equal to the sum of the opposite interior angles. You add those two together. All right, so let's look at an example. The worksheet software that we're doing likes to use a question mark in here. I'm going to change the question mark to an X. All right, so the exterior angle is equal to the sum of the opposite interior angles. So 120 is going to be equal to X plus 25. So this angle out here is equal to the sum. Highlight this angle here and this angle here, which is the 25. Oh, that's not what I wanted. So you solve that. Excuse me. All right. If I had good editing skills, I would edit out my sneeze, but I thought anyone was going to get that far in the video anyway. So you made it this far. Congratulations, you hear me sneeze. 120 minus 25 is 95. So that angle in there is 95 degrees. Let's do one more. So real quick, so this time we are trying to find the exterior angle. This one's even easier. So the exterior angle is equal to the interior angles added together. So X is equal to 19 plus 91. We don't need to solve anything. 19 plus 91 is 100. And that is it. That will do it for today's lesson. We'll see you guys next time when I forget what we're doing. We'll see you next time.